Hello everyone, this is Revati M, Assistant Professor, Department of Computer Science, Artificial Intelligence and Data Science, Dr. SNS Rajalakshmi College of Arts and Science. In this series, we are discussing about the introduction and programming to data science. Today, we are going to learn about PCA, which stands for Principal Component Analysis. PCA is a statistical technique used in data science and reduce number of features in a data set. Okay, it reduce the number of features in a data set. Sometimes we have too many columns or variables and it becomes difficult to analyze. So what PCA does is it converts the original correlated variables into new variable. It's called principal components. These components are uncorrelated and they keep the most important information from the data. In simple words, we have to say PCA help us simply the data without losing much importance in information. Next, we see what are the key concepts of PCA. So first in variance, variance means how much the data is spread. Next one is principal components. So these are new access created from the original data. The first component called PC1 captures the highest variance. PC1 captures highest variance and PC2 captures second highest variance. So we have in values and even vectors, and vector shows the direction of the eigenvectors shows the direction of the data. Then eigenvalues tell us how important the direction is. Is it clear? Next, we see the PCA is used in real life. Where we are using. What are the real world application we are using? PCA is used in image compression. So where it reduces the size of image, it is used to face recognition system. It is also used in stock market analysis. To understand pattern. In bioinformatics, it helps in analyzing general data, and in recommendation systems, it's like Netflix, Amazon. PCA helps in reducing complexity. So PCA is very useful in many real world applications. Next, we see what are the PCA workflow. So let's understand how PCA works step by step. First, we have to collect the data set. Next, we standardize the data, so all features on the same scale. Then we compute covariance matrix to understand relationship between features. After that, we calculate eigenvalues and eigenvectors. So we already know eigenvalues is the directions and vectors. Next one is then we select the top k principal components. So select top k principal components. Finally, we transform the original data into a new space using these components. These are the PCA workflow step by step. So here the diagram. First, we have to collect the data set, reduce the number of features so the data becomes simpler. It removes correlated features, improve visualization, especially when we are reduce data to 2D to 3D model. It also helps in reducing noise in the data. So PCA makes data easier to understand and work with. So already known, first one is the data, collect the data. Next one is the standardize the data. Third one is it's a covariance matrix. Then we have to calculate the eigenvalues and eigenvector. Then select top k principal components. After that, we have to transform original data into a new space. These are all the PCA, how it works in step-by-step process. Okay. Next, what are the limitations, advantages in PCA? So it's reduced dimensionality, it removes correlated features, improve visualization, it reduces noises. So loss of interoperability works best with linear data, sensitive to scaling, important features may be lost. So what are the tools and libraries we are using to implement PCA? Okay, so we use different tools and libraries. In Python, we use NumPy. So and pandas for data handling, and for PCA we commonly use skit learner. For visualization we use matplotlib and seaborn. These are all the tools and libraries we are using for the PCA. We come to the end of this section. Finally, let's conclude. PCA helps us simple complex data set. It retains important information while reducing dimension. It improves the performance of machine learning models, and it is an essential technique for every data scientist. So understanding PCA is very important in data science. I hope you enjoy this section. Thank you.